Hey guys, so I just wanted to come on here and record a video for your e-learning assignment today. I'm sure that you have learned about the volume of prisms, cylinders, and spheres before. However, it might have been a while since you've seen it, so we're going to review that today. So your assignment for today is we are still in Unit 5, so we're looking at volume of prisms, cylinders, and spheres, and we are on outcome number 3. So for those of you who have had me before, you know all about standards-based grading. For those of you who have not, I will be explaining that if I haven't already within the next couple of classes. But basically, there are going to be a certain number of outcomes, one outcome per topic, and you're going to be tested on those outcomes. So this outcome, the standard, is volume of three-dimensional figures. All right, so that is standard GTS4. That's more for me than for you, but that's just the Indiana State standard that we are covering today. We are looking at, like I said, prisms, cylinders, and spheres. However, we're going to look at some overall vocab. So the first word is a polyhedron, which is a three-dimensional figure that's bounded by polygons. That's all that means. So that would be like a rectangular prism like we see right here. So if you notice, obviously it's just rectangles all around. And then we also have a pyramid. So a pyramid is bounded by triangles and then a rectangular or square shape on the bottom. The non-polyhedra are the cylinders, the cones, and the spheres. Because those are not bounded by polygons, they're bounded by, like there's circles involved in those ones, so there's not like vertices and edges, right? So that's the difference. What we're focusing on today is any type of prism, which can be any type of polygon. It doesn't have to be rectangular, and also cylinders and spheres. So we are looking at volume, which is just the space that fills the inside of that three-dimensional figure. So if you think of, for instance, the water in a swimming pool, the amount of water that fits in the pool is the volume of that pool. So we're not looking at the outside of it, we're looking at what would fit on the inside. So how much space is there inside? So now we're gonna get into some formulas. For any prisms and cylinders, it's the same exact formula. You take the area of the base and you multiply it by the height of the actual prism or cylinder. So if we're looking at a rectangular prism, such as this one right here, the base of the prism is the shape that makes up that prism. So in this case, it would be a rectangle. So you would have to take the area of the rectangular base and multiply it by the whole height of the prism. And we'll see examples that will make that make a lot more sense. Same thing with if you had like a triangular prism. You would take the area of the base, which the base is obviously a triangle, so that's going to slightly differ from a rectangular prism. And then a cylinder is the same idea, except the base is always a circle. So you have to take the area of the circle and multiply it by the height of the whole cylinder. So this is where our area formulas are going to come in handy. So you're going to want to look back at what we did with area a couple days ago. And then we have the sphere, whose formula is 4/3 times pi times the radius cubed. So remember cubing something, so I'm going to say cubing means that we take it and we multiply it by itself 3 times. So whatever the radius is, you multiply it by itself 3 times. And there is a button on your calculator that will do that, and I will show you that. All right, so you take 4/3 times pi times radius cubed. And remember, pi is just 3.14, but you can use the pi button on your calculator. So that is for the volume of a sphere. So for that, we're thinking like a globe or something of that sort, or like a basketball, a volleyball, any ball. The volume inside of a sphere is calculated by this formula, and that's never going to change. So that one's actually pretty nice. It's a set formula. The ones that become a little bit more difficult is when we think of the prisms and the cylinders, because we have to pay attention to what kind of base we're dealing with. So I'm going to show you some examples, and then you're going to do a homework assignment over this that are very, very similar to the examples that we go over, which is big B times A. First page for that. The volume of a cylinder is still the area of the base times the height. To the first page and look at our formula again. This is just the set formula. That's never going to change for the volume of a sphere. So it's 4/3 pi r cubed, or pi r to the third power. So if you flip to the next page of these notes, the very first problem looks like a rectangular prism. So we're going to have to look back at what our formula was. Okay, so we're going to say volume equals big B times H, where big B is the area of the base. And remember, the base in this case would be a rectangle. So you have to do base times height for that rectangle. Then you multiply by the whole height of the prism. So that is the height of the prism, not the height of the base. So let's look at this figure a little bit closer. So the base, we know this is a rectangular prism, which means that the base is a rectangle. So I'm going to write myself a note that says this is a rectangular prism. Right, so the base is a rectangle. There are actually two different ways that we can do this one. So I'm going to show you both. So one of the rectangles that I see is this one right here. So if you think of this as the base, it has the dimensions 12, and then this length is 8. So that's 12 and 8. Okay, so the area of that base, the area of a rectangle, like we learned in class the other day, is just base times height. So if I'm looking at this as the base, the area would be 12 times 8. So I'm going to do 12 times 8 in my calculator, which is 96. So all right, equals 96. Now I have big B. I found the area of the base. What I need now is the height of the entire prism. So that's going to be this guy right here, which is a 5. So I need to do 96 times H, which is 96 times 5. So I'll go back to my calculator, type in 96 times 5, which is 480. And the units are going to be feet cubed, because we always use cubic units when we're doing the volume, because we're multiplying 3 different numbers together. So we had feet times feet times feet, which is feet cubed. The other way that I can get this exact same area is if I were to look at this other rectangle. So I'll use a different color. Actually, let me just erase what's on here. Okay, so now I'm going to look at the base as being this one right here. So that means the dimensions are 5 and 8, which means the area of my base, so big B, is 8 times 5, which is 40 feet squared. So that's the area of the base. Now I multiply that by the height. The height is now 12. That's the other dimension we haven't used. So 40 times 12, again, I should get the same answer, is 480, and again, feet cubed. So that's the answer to number 1. You take the area of the base and you multiply it by the height. Because that was a rectangular prism, you were allowed to choose which rectangle was your base. That's why there were 2 different ways that we could do it. The next example is a cylinder. So if you're not familiar with a cylinder, I normally think of it as like a can of, like a can of soup. Some type of canned good is a cylinder. So I'm gonna go ahead and name this as my cylinder. And then what we're gonna do is look back and think, what was our formula for the volume of a cylinder? So I'm gonna go back. Okay, so I'm using that volume equals big B times H. The difference though is, what is the area of the base of a cylinder? Well, the base of a cylinder is always a circle. So that means that big B is always going to be the area of a circle. So let's think back to area of a circle. So that would be from like Tuesday and Wednesday's class. Area of circle is always pi times r squared. So that's what this is going to be right here. That's always what big B is for a cylinder. And then H is just the height. So the height in this case is pretty obvious. That looks like 11. Okay, so that's my height. How do I find big B though? That's gonna be the hardest part. So what I'm gonna do is I'm gonna look at my shape and think, okay, do they give me the radius or do they give me the diameter? So we're gonna find big B. We know it's pi r squared. Looks like since they give me the whole length across the circle, they're giving me the diameter, which is 8. So they tell me D equals 8, but I want the radius. Remember from our area notes that the radius is just half of the diameter. So half of 8, which is 4. So radius is 4, which means when I go back to find big B, I have B equals pi times 4 squared. So I just put that in my calculator, and you can use the pi button or you can use 3.14. Okay, so I'm getting about 50.24 for the area of the base. And whether you use pi or 3.14, so the pi button or 3.14, you might get a slightly different decimal, but it should be in the same ballpark. Okay, so I'm getting 50.24 for the area of the base, and then I need to multiply that by the height of the cylinder, which is 11. So volume equals big B times H. We said big B was 50.24, and since that's an area, it's going to be in miles squared times the height, which is in miles. Now I'm going to multiply those two numbers on my calculator. So 50.24 times 11, and I get 552.64, and again, it's miles cubed because it's a volume. So that's how we find the volume of a cylinder. So just remember, volumes of cylinders and prisms are essentially the same formula, but what's different is what is the area of your base. So that big B is the big thing that's a little bit different. The next figure that we're going to look at is the sphere. So the formula for the volume of a sphere is the one that's a little bit different. So we're going to go back. So I'm going to go ahead and write down my formula. Volume equals 4/3 pi r cubed. Okay, so the 4/3 is not changing. Pi is just a number, so that's not changing. What I need to plug in is r. So all we need to do for finding the volume of a sphere is we need to identify what r is. So remember, that's the radius. And it looks like in this picture, I'm actually given r. So I'm going to go ahead and highlight that. Remember, r just goes halfway of the circle, right? So they give it to me. So in this case, r equals 4 inches. So I'm going to plug that in and then follow my formula. So when you plug this in your calculator, what you're going to do is type the fraction 4/3, so 4/3, then hit your pi button, or you can type in times 3.14 and put those parentheses. Then you're going to hit multiply again, put parentheses around your 4, and then put it to the 3rd power. So there might be like a little caret button on your calculator that does that for you. If you are struggling with the calculator part of this while you're doing this e-learning, do not worry about it. Just leave it in this form because that shows me that you know what to type in the calculator. I would recommend using the Desmos Scientific Calculator. I personally think that one is the easiest to use. So on your iPads, you just have to type in Desmos Scientific Calculator just onto Google or whatever you prefer to use for your search engine. So we would say Desmos Scientific Calculator. If you type that in, it's going to pull up a nice calculator for you where you should easily be able to type this in. I will try to get a video uploaded of me using that calculator in case you're confused, but just email me with any confusions with the calculators and don't stress about it too much. As far as this e-learning assignment goes, if you leave it in this kind of form, I'm okay with that. So when I actually type this into my calculator, I am getting 267.9. If you want to round up, it'd be 0.95. So I'm okay if you go 1 or 2 decimal places, and my units would be inches cubed because I cubed my unit up here. And remember, volume is always to the 3rd power for your units. All right, we just have one more. Okay, so watch this video to help you with the assignment. There's nothing on the assignment that wasn't included on this video, but if you run into any issues, let me know, like if you don't know what the shape is or how you find the area of the base. But make sure you look back at your notes from Tuesday as well, because that's going to have all your area formulas on it. All right, so page with only 2 examples left on it to do. I wanted to show you these 2 because there's a couple that are similar to this on your homework assignment. So number 4 is what we call a trapezoidal prism. So you're going to write the word trapezoidal prism. The reason it's called a trapezoidal prism is simply because its base is a trapezoid. Okay, so what that means is if you look at this really, really closely, what you'll see, and I'll use a different color, is that the base of this prism is a trapezoid. Okay, so what we have to do, because it's a prism, is we just need to follow our volume for prisms. It's in general, same thing we did for the rectangular prism, which is volume equals the area of the base times the height of the prism. However, in this situation, the base is a trapezoid, so that means our area of the base is a little bit different. So because it's a trapezoid, we know the area is 1/2 times B1 plus B2, because remember, a trapezoid has 2 different bases, and then multiplied by the height of the trapezoid itself. So the area of the base is this equation. And then this other H stands for the height of the prism. So don't be confused by the 2 different H's. The one in the area formula is just talking about the height of the trapezoid. And then the one in the volume formula is talking about the height of the prism itself. So first, we're just going to worry about finding the area of the base. That's the hardest part. So because it's a trapezoid, like I said, we're following this formula. So I would write down, what is my B1 and what is my B2? Remember, it doesn't matter which is which, but one of them is the top base, one of them is the bottom base. So I know right here, this 3 is one of the bases. So I'm going to call B1 3 meters. The other base is this guy up here, which I can see is labeled 8 meters. So that's going to be B2. So I have my B1, I have my B2. Now I need the height of the trapezoid. So the trapezoidal height is this thing right here, because this is taking me from the bottom of the trapezoid to the top of the trapezoid. So I'm going to say H equals 4.3 meters. Now I have all the information that I need to find the area of the base, or big B. So we're going to do that now. Right, so once I have all of this info, I'm going to plug it in. So area is 1/2. I'm going to plug in B1 plus B2, which is 3 plus 8, and then multiply by 4.3. So in my calculator, I know 3 plus 8 is 11. So that's what that simplifies to. So I have 1/2 times 11 times 4.3. So I'm going to type that in my calculator. And I'm getting 47.3. And again, because it's an area, that's in units squared. So the area of the base, or big B, is 47.3 meters squared. But I'm not done because I want the volume. So I still have to multiply it by the height of the prism. The height of the prism is the thing that goes from trapezoid to trapezoid. So the thing that connects the 2 bases. In this case, it's hard to see because of the way the trapezoid is tilted, but it's actually going to be this length right here. This is the length that takes me from one base to the other. So that means the height of the actual prism is 4 meters. So it's easy to accidentally say it's 4.3, but that's just the height of the trapezoid itself. The 4 meters is the height of the actual prism. So I'm going to say that the volume equals 47.3 meters squared times 4 meters. And then I will go and put that in my calculator. And I'm getting 189.2 meters cubed because it's a volume. So I know that seems messy and like a lot, but all we did was find the area of a trapezoid and we multiplied it by the height of the prism. So I'm going to do this last one with you, and then I promise I am done, and you guys are going to go be free to do your assignment. So this is a picture of a triangular prism. And I know that because triangles are the bases. So I'm going to go ahead and I'm going to write triangular prism. So here's my base, the triangle, right? Okay, so I have two bases. It doesn't matter. They're the exact same. So the lengths are 3, 4, and 5. I know that's 5 because it's listed over here. I could also do Pythagorean theorem to figure out that this is the slanted height. Notice this is a right triangle. When we're taking the area of a right triangle, the height is always this guy right here. So if I'm looking at this, I'm going to draw it separately. This is the triangle I'm taking the area of. Okay, so I have a 4, a 3, and a 5. So all I did was pull that triangle out so you can see it better and see it right side up. So remember, the 5 is the hypotenuse, and then 3 and 4 are the legs. Because it's a triangular prism, my overall equation for volume is still area of the base times the height of the prism. Now, the area of the base this time is a triangle because it's a triangular prism. So the area of a triangle is just 1/2 times base times height. And then this guy is the height of my prism. So because this is a right triangle, it makes my life a little bit easier because the height is pretty easy to see. So the area of my base this time in the triangle that I drew for you on the outside, it's the same as the one in here, is 1/2 times 3 times 4. So all I'm doing is plugging in the numbers from my base. Okay, so when I do that in my calculator, I get 1/2 times 12, which is going to give me 6. So the area of the base is 6 meters squared. Now I need to look at the height of the prism. Remember, that's the thing that connects the two bases. So where is the line that's connecting those two triangles? And that's going to be this 7 right here. If you notice, those triangles are being held together by this height, which is 7. So times 7 meters equals, and that's going to be 42 meters cubed. And again, it's cubed because it's a volume. So that is all I have for you for this little lesson on volume of prisms and cylinders and spheres. So if you have any questions after watching this, let me know, but use this to help you with the assignment. All I have for you guys, again, email me with any questions.